This lesson is about simplifying radicals. A radical is any expression that contains a radical symbol, such as this right here. That would be a square root. There's an understood root of 2 right here. But it could be a square root, a cubed root, or anything. This would be a fourth root. So those are radicals. But what we are going to be concerned with are square roots. So we're going to see something like this, and there will be a radicand or a number written under there. So here is the radical, the square root of 25. And so if I ask you what the square root of 25 is, a lot of you can answer. The square root of 25 is 5. Okay, why is it 5? What does that mean? Okay, so a square root is, if you think of a square, like I've drawn a square right here, if the area of the square is 25, then the two numbers that the sides of the squares could be would be 5. 5 times 5 is 25. So that's what we mean by a square root. We're actually looking at the area of a square, and we're looking for two integers that are the same, that multiplied by each other gives you the area. So in the second one here, the area is 16, and so the two numbers that multiply together for the side of that square is 4 times 4. Now in this last one, it said the area is 10, okay? Well, there is not an integer that we can multiply together to get 10. 3 times 3 is 9. Oh, so I wrote this wrong. It's not between 2 and 3. I'm sorry, it's between 3 and 4. Because 3 times 3 is 9, and 4 times 4 is 16. So 10 is somewhere between 9 and 16. So the square root is somewhere between 3 and 4. Maybe 3.1, 3.2. You could put that in a calculator and you'll get an estimate. But when we're dealing with radicals now, we want to look for some exact answers. So let's see where we go from here. Okay, so decimals are approximations, and we want exact answers. So we're going to look at some rules of the radicals. Okay, and first we're going to talk about simplifying radicals. So in order to simplify a radical, if you can rewrite the radicand, that number, the square root of 25, the radicand is 25. Well, if the square root of 25 we said is 5, so we don't need to worry about simplifying that one, because we can take a square root and it's what is called a perfect square. But if you can rewrite the radicand of a square root as the product of two numbers where one of them is a perfect square, then it can be simplified. Okay, so what are perfect squares? Perfect squares are numbers that can be expressed as the product of two equal integers. What do we mean by that? Well, if you take 2 times 2 and multiply it, you get 4. So 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square, and so on. 4 times 4 is 16. So you can just take any two numbers and multiply them together. 20 times 20 is 400. So 400 is a perfect square, because we know that the square root of 400 would be 20. Okay, so those are perfect squares. So that's what you can start to become familiar with. Okay, so let's go now and actually simplify some. So let's look at the square root of 25 we said is 5, the square root of 16 is 4, and the square root of 10. Can we simplify that? Can you rewrite 10 as the product of two numbers where one is a perfect square? Well, the only factors of 10 are 10 and 1 and 5 and 2. And 5 is not a perfect square, 2 is not a perfect square, so we can't simplify it. So the square root of 10 is simplified. So now let's look at one that we can simplify. The square root of 8. Well, I can rewrite 8 as 4 times 2. Okay, and 4 is a perfect square. So I can rewrite that as the square root of 4 times the square root of 2. The square root of 4 is 2, so that comes out from the radical, and the square root of 2 stays under the radical. because we haven't simplified that part. And so 2 times the square root of 2 is the simplified form of the square root of 8. Okay, let's look at the square root of 50. We can rewrite 50 as 25 times 2. So we can rewrite that as the square root of 25 times the square root of 2. We know that the square root of 25 is 5, so that comes out from the radical. And we're left with 5 times the square root of 2. All right, well, what happens when we get one that we can't do in our head? Find a factor. The square root of 216. Okay, I don't know how to rewrite 216. I could start playing with numbers, but probably the most systematic way to do it, if you don't know what it is to make a factor tree. So hopefully you remember this from earlier in algebra, but I take 216 and I just break it down into a tree of factors. 216 is divisible by 2. I get 2 times 108. That's divisible by 2. I get 2 times 54. And I keep going. 2 times 27. Okay, 27 isn't divisible by 2, but it is divisible by 3. So 3 times 9. And then 9 is divisible by 3 and 3. Okay, so now I've used my factor tree and I have all of my factors of 216 with prime numbers. Now, what we are looking for are pairs of factors. So I have a pair of 2's and I have a pair of 3's. So if you take all of your pairs and multiply those together, so I have 2, 2, 3, and 3. So 2 times 2 times 3 times 3. And that's 2 times 2 is 4, 12, 36. Okay, and then take what's left. I have another 2 and another 3, and I multiply those together, 2 times 3, and that's 6. So what we've done is now we can say that 36 times 6 is 216. And this, when you multiply your pairs, will always be a perfect square. So I'm going to rewrite 216 as the product of 36 times 6. And we know that the square root of 36 is 6. So it is 6 times the square root of 6. Okay, this usually takes a little bit of practice to get the hang of it, so I have a few now for you to look at. All right, so I just did the explanation there of looking for the pairs of factors, and then we come up with the square root of 16 is 6 times the square root of 6. So now let's simplify the square root of 96. And if you want to pause the video and try it yourself, I would suggest that. But what I'm going to do is I am going to take 96 and I'm going to make a factor tree. So 2 times 48, and then 2 times 24, 2 times 12, 2 times 6, 2 times 3. Now I look for pairs of factors. I have 2 and 2 and 2 and 2. And so I'm going to multiply 2 times 2 times 2 times 2, 4, 8, that is 16. And then I have left down here a 2 times 3, which is 6. So what that tells me is that these two numbers here, 16 times 6 is equal to 96. So I'm going to rewrite the square root of 96 as the square root of 16 times 6, which is the square root of 16 times the square root of 6. The square root of 16 is 4. So there is my answer. That is my simplified radical of the square root of 96 is 4 times the square root of 6. Okay, so let's look next at 48. And again, please pause and try and do it yourself. Okay, the square root of 48. Well, I'm going to make my factor tree. 2 times 24, 2 times 12, 2 times 6, 2 times 3. I look for pairs. I have 2 times 2 and 2 times 2. So 2 times 2 times 2 times 2 is 16. And then I have this 3 over here. So I rewrite it as 16 times 3. The square root of 16 is 4 times the square root of 3. The last one is the square root of 450. Try and write this small enough where I can put it all in here. 450. So that's going to be 2 and 225. That's not divisible by 2, but it's divisible by 5. Let me see. I'm going to use my calculator. 225 divided by 5 is 45. And then 45 is 5 times 9. And 9 is 3 times 3. So now just look for pairs. I have a pair of 5s and I have a pair of 3s. So 5 times 5 times 3 times 3. 25, 75, 225. And then I have this 2. So I'm going to rewrite it as 225 times 2. And then the square root of 225, if you're not sure, just put that in your calculator, and it is 15. So my answer is 15 times the square root of 2. Okay, there's 2 more examples that I want to show you that I didn't put on my notes, and that is because it's on the practice. What if you get something like this? The square root of 75 over 16. Okay, we're going to look at some more rules of radicals tomorrow, but let's go ahead and look at this one. You can just rewrite this as the square root of 75 over the square root of 16. And so now you just work with the 2 numerator and denominator separately. The square root of 16 is 4, so we're good there. So now we just need to worry about this 75 on top. And so then we just go back and we get 25 times 3, 5 times 5. So here are my pairs. So I can rewrite that as 25 times 3. The square root of 25 is 5. And so you just treat the numerator and denominator separately. And we'll look at some more rules later, but that should suffice for now. And then the last one is one like this. There's a problem that looks something like this: 4 times the square root of 32. So here, this 4 is already outside the radical, and so we're just going to leave it there. We're going to simplify the square root of 32. So 32 is 16 times 2. You might already notice that that 16 is, well, let me go ahead and do it this way. 2 times 8, and then 2 times 4. Let me rewrite that. That's kind of messy. Sorry about that. 4 times the square root of 32. Okay, so let me do 32 is 2 times 16, 2 times 8, 2 times 4, 2 times 2. So we have a pair of 2's and another pair of 2's. So I'm going to rewrite the square root of 32 as 16 times 2. The square root of 16 is 4. So you get 4 times the square root of 2. So now let's come back over here. So we have 4 times, and now we simplified the square root of 32 to 4 times the square root of 2. So this 4 just comes here, and you multiply 4 times 4, and your answer is 16 times the square root of 2. We'll spend a little more time with that tomorrow, but now I think you have enough information to do the practice.